Hi everyone, it's Mr. Baker here with another physics video. Today we're going to be looking at the speed of sound. So today we're going to be looking at the speed of sound and we're going to be answering this question: how can we work out how far away lightning is? So first of all we need to remember how to work out speed, and to calculate speed we need to know the distance something has travelled and how long it has taken to travel that distance. And we get this equation that speed equals the distance travelled divided by the time taken. So if we want to measure the speed of sound, we can set up something like this. So we need to know how far something has travelled, and we need to measure the time taken. But what we can do is we can see when a sound has been made. So if we have two bits of wood and we clap them together above our heads, or if we have a starter pistol, like in the picture here, when the pistol goes off, we'd be able to see the smoke that gives off. And when the smoke is given off and when the sound is made, we can then let the sound travel to us. So if we go a fairly long distance away, about 170 meters or so away, for example, then we can measure the time it will take for the sound to get to our ears. The light just gets to our eyes almost immediately, and then the sound will travel not quite as fast. So this gun will go off, and the sound will travel to our ears. And if the sound travels about 170 meters, it will take about 0.5 seconds. So we've just said that the speed equals the distance divided by the time. So the speed of sound will equal the distance that sound has travelled divided by the time taken. So if we say that the distance was 170 meters and the time was 0.5 seconds, then the speed of sound would be about 340 meters per second, which is about what it is. So that's pretty much the end of the lesson on the speed of sound. And we said at the beginning, we asked this question: how can we work out how far away lightning is? So we've kind of seen an example of this. If we have an object that we can see, like lightning, we'll be able to see that before we can hear the rumble of thunder seconds later. So we can see a lightning bolt go off, and then we can count. And if we count how long it takes for it to reach us, and we know the speed of sound, then we can calculate the distance that the lightning bolt is away from us. And that's how we did it. Okay, so I've been Mr. Baker. This has been another physics video, and I will see you next time. Thanks very much.